So we are going to determine the amplitude of the following. We're going to combine what we know about transformations. For each of these as well, you can write the fact that we are going to graph these as well so we get a sense of what's going on. And what we're really looking at is what happens when you put a value in front of either sine x or cos x. For the most part right now, we're going to worry about what's happening to sine x and cos x while we're graphing. And the first letter that we put there is an A because it's the first letter in the alphabet, and it's also helpful to remember because A stands for amplitude. Now, what we have is whenever a value is out in front from our transformation unit, you know that that multiplies the y values. That makes a vertical stretch. So if our amplitude of a regular sine graph and regular cos graph was 1, what happens with a value in front is that's going to change the amplitude to be whatever the number in front is. So if you multiplied everything by 2/3, now your amplitude is going to be 2/3. So on this one, your amplitude is going to equal 2/3. In this one, your amplitude, and since amplitude is a distance, it's always a positive number, this one, the distance is going to be 4. That negative in front of the second one is also going to be a flip. And if our y values become negative, remember that flips it over the x-axis. So now to quickly graph these ones, again, every time you graph a sine graph, you're going to write out the period here, and our period is still going to be 2 pi. And then along here, we usually put 1 and -1 because that's its amplitude. Now, we're going to go up to 2/3 and down to 2/3. Our sine graph always starts on the center line, then goes to a maximum, back down to the center line, down to the minimum, and back to the center line. And so here's a quick graph of y equals 2/3 sine x. So one of the shortcuts we're going to do, instead of taking these 5 points from our parent graph, from our original graph, and multiplying them by 2/3, we're going to just label our new maximum and our new minimum with our amplitude, and we'll be able to graph it quicker than what we did with our transformations unit. Okay? For part B, again, it's a cos graph. We're going to label our period of 2 pi and split it up into 4 equal sections. Now our amplitude is 4, so we're going to go up to 4 and down to -4. And a cos graph started at its maximum, so we're going to start at this point up here. Then it goes to the center line, down to the minimum, back to the center line, back to the maximum. That's normally how a cos graph happens. But what will that negative do? That negative in front will flip this point down over here, and this one up over here, and this one down over here. So in the end, instead of starting at our maximum, a negative cos graph will start at a minimum. But it still has an amplitude of 4 because the distance, right? The distance from a maximum or a minimum to its center line is 4. Questions that practice amplitude are 3, A and B, 4, 5, and 9.